All right, so you tried the practice problem, so let's see how you did. Again, this is an impulse momentum problem, so we have that big equation, and we need to pick the parts that fit our needs. So in this case, you were looking for the impulse, so you wanted to pick J, and they gave you a graph, so you wanted to go ahead and pick the area of the force versus time graph. Now, when you did this, many of you might have missed this. This was in kilonewtons and milliseconds. If you just kept those values, you would have gotten kilonewtons times milliseconds, but you still would have gotten the 12 numbers. So just make sure you're careful about those units though. Also, it noted that this was a force to the left. So when we saw it above the axis, this positive is telling me left. That means if I get a negative number, it's to the right. So I go ahead, calculate that area. You got yourself 12 Newton seconds left. Now in part B, they're wanting you to find a final velocity after this impulse. So I'm going to go ahead and take that impulse that I just found and pick another part of the equation, the one that has velocity in it. In our two situations, one, the initial velocity was 0, so I plug in my mass, my impulse, my initial velocity, and I solve for that final velocity. I'm getting a positive number, and remember our positive direction is left, so that's 80 meters per second left. Make sure you're being specific about those directions, not just leaving it as positive, but really stating that direction in words. For the second one, the initial velocity was 30 meters per second to the right, which is my negative direction in this case, so I have to put a negative 30 in there. Put that information in and I get positive 50 meters per second for my final velocity, which means 50 meters per second left.